Hello and welcome to a quick introduction to the new Layout app. Note this doesn't work on Internet Explorer. The old Layout app only works on Internet Explorer. The new one should be fine on just about anything except Internet Explorer. Anyway, first thing to do is to download the design file for the circuit that we'll be building in this lab. So right click on this link, and in Chrome it's Save Link As, so save it somewhere sensible. And then we're ready to fire up the Layout app. Click on this, and the first thing to do is to load in the design. There's three panes here. This contains the circuit diagram, this is the layout, and this is just for controls. Click Load or Save, and load in the file that we've just saved, and it looks like this. We can minimize this a bit, we don't need much of that anymore. This is the layout pane, where we will be doing the design of the layout. This is the circuit diagram that we're trying to move that in so you can see it. The circuit diagram that we're trying to reproduce on a real bit of veroboard. Now, these are the components down here. 2 capacitors, 2 transistors, 4 resistors, 2 LEDs, a bit of veroboard. The 9 volts here and the 0 volts there are the 2 terminals of the battery that you'll be using in this application. Veroboards have rows of holes which are connected together by strips of copper on the back of the veroboard. If I click on this veroboard, the app shows you the back of the veroboard as well. You can use the mouse wheel to zoom in and out, and the mouse itself just grab anywhere in the background and move the whole design around. If I click on the veroboard, I can get a back view of the veroboard showing these copper tracks that are used to produce the wires that connect together the components. So let's start. I could decide that my top row here was going to be all set to 9 volts. That wouldn't be such a bad idea. If I click on this 9 volt hole there, a wire appears, and I can just connect the wire directly to any of the holes on the top row. You will see that all of the holes on the top row have now gone red. That's because all of the holes on this row are now connected to 9 volts because there's a big copper strip on the back here. Now, there are 4 components which have one of their leads connected to 9 volts, 2 LEDs and the 2 47K resistors. So this is a green LED, it's this component over here. When I click on that LED, you'll see a blue line appears around the body of the component in the circuit diagram, and the 2 pins of the component go red and green. If I put this green LED with 1 pin there, connect it to that hole, all of the other pins around here light up red because they are connected to this pin of this LED. And if I connect the other pin of the LED to this hole there, then all of the pins along here go green, rather all of the holes along here go green because they are now connected to this point in the circuit there. It's always a good idea to have a look at the physical sizes of the components before you finalize your layout. If you do that, you'll see that LEDs quite like to be in 2 adjacent holes like this. It means you can fit the body of the LED flush to the board and make a very solid and mechanically strong joint. Anyway, we've now got an 820 ohm resistor there, which we need to connect to the cathode, that's this terminal of the LED, and then down to the collector, that's this terminal of this transistor. Well, these are the 820 ohm resistors here. You can tell because of the color code, grey, red, brown is 820 ohms. If I click on this 820 ohm resistor, you'll notice that both of the 820 ohm resistors on the circuit diagram have a blue line around their body, and that's because the layout doesn't know which 820 ohm resistor this one is yet. Resistors are not polarized, which means it doesn't matter which way round you put them. So I could put the resistor in the other way round, but why would you? Let's just get the resistor and put it in there. And now, the cathode of this LED, that's this point in the circuit here, is connected to this lead here of this 820 ohm resistor, which you want because they are connected together in the circuit diagram. So that's good. Next, well, let's look at these transistors down here. Let's move a transistor onto the circuit diagram there. If I zoom in, you'll see that there are little letters, E, C, and B. And in fact, there are little letters on the circuit diagram as well, if you can see them, C, B, and E, indicating the collector, the base, and the emitter of this transistor. And we've got to get the transistor wired up the right way round. Now, the collector here is what needs to be connected to this pin of this 820 ohm resistor. So I could put the collector there, and say the emitter there, and the base there. It's not a brilliant design, because if you look at the actual physical shape of a transistor, in order to fit it into the circuit board like that, you couldn't mount it very closely to the board. But it would work. Electrically, it has the connections that you need. The other point that we need connected to this point down here, other than this node of this resistor and the collector of this transistor, is the positive terminal of this capacitor. Well, there's only one 6.8 microfarad capacitor in the design, so it must be this one. Electrolytic capacitors, this is an electrolytic capacitor, have a light grey stripe indicating their negative terminal, which is not the positive terminal. So this is the negative side over here. So it's this green positive terminal that needs to be connected to this 820 ohm resistor and this transistor. So I could put this capacitor onto the circuit board like that. And then the resistor, the collector of this transistor, and the positive terminal of this capacitor would all be connected together along this row of the veroboard. The problem is that the positive terminal of the capacitor is also connected together because there is a copper track going all along here. What can we do about that? Well, if you click on the veroboard, the reverse side of the veroboard will appear. And what you can do with veroboards is break the tracks. Break a track so that now this side of the capacitor is no longer connected to this side of the capacitor. If I select the resistor, you can see that this leg of the resistor is connected to these holes, but not to these holes over here. But the only other thing to mention is if you wanted to add another wire on the veroboard, just click on a hole, drag away. If you want to change the color of the wire, then click on this colored blob there. If you want to get rid of a wire, move the wire so that it has 0 length and it will vanish. And if you decide that you've put a track break in the wrong place, click on it again and it will be remade as new. There is a checking facility. If you've got your circuit diagram correct, then when you press check design, it should say 100%. I've only got 8.3% because I've only wired up this resistor, this diode, one leg of this transistor so far. It's given me a score of 8.3. You need to get to 100. Nothing else will do. If you don't get to 100, it won't work. I think that's about it. Any questions, let me know. Good luck.